Thank you, Atina, for a kind introduction, and thank you, everybody, for being here and attending this talk, which we'll try to, let's say, discuss a little if the measurements that we get from wearable devices really match what user perceives, so their perceived physiological states. So when I started designing this presentation some weeks ago, I was not quite sure on how to start it, but then something interesting happened. So it was a Sunday morning, and I was wearing multiple wearable devices on me. I'm still doing it. And I started to check what the Oura Ring was reporting me in the morning. So I woke up, and it told me, yeah, you're quite ready to face your day. So 82 readiness. So I didn't recover that much from the night, but still feeling quite well. And I checked in with another app. That was the Whoop one. Things are not so good. So 32% recovery. So you're not ready to face a Sunday with your daughters as well. So of course, told me that no, during the night you were not able to recover yourself. Then I checked in with my very, let's say, personal Garmin, 6 years of use. Yeah, everything is completely fine. So you're recovered completely from your Saturday. You're ready to do a lot of activities during the day. So of course, as you can see, I mean, they are based on the same sensors, but of course they provide different interpretations of the data. But at the end, I mean, okay, I checked in with all of them, but at the end, what it really matters is how I perceived it. So how did I actually sleep? So did I sleep well? Did I recover well or not? Because at the end, what it really matters, of course, we have all these measurements, but what is really important, and I think that also what we saw from the talks in the first half, is what the users also perceive for their sleep quality. So not only what these devices provide us, but also what the users perceive. So this talk will try to, let's say, talk a little about this mismatch that we see. Because as Dr. Soriala was talking before, these wearable devices really provide us with a way to passively monitor people, their health, their behaviors in a really unobtrusive way. And we can use them for a lot of stuff. So we can use them to drive some interventions. So we can use them to, let's say, help people improve their sleep. So that will be the topic of our last talk. We can use them for longitudinal and in the wild data collection, so to monitor people during their normal life without having them in the hospital. And they can be used also to, let's say, offer personalized approaches to treatment. But of course, one of the major issues is that there is this mismatch. So we have a mismatch between those scores that these wearable devices provided. So I'm not talking about, of course, the raw data that they have, which was the topic of the accuracy that Oriela was discussing before, but the scores that they provide to the users and what the users instead self-report and their subjective interpretation. So the goal now, so today, will be to, let's say, see what in sleep, so in the context of sleep, what is this mismatch? So do they match or not what the users perceive? And in order to discuss this, we'll consider a scenario that is what Max was talking before, so the use of some AI algorithms to reduce work-related stress disorders, so to prevent burnout through the use of a lot of data. So some contextual information that we have, physiological data that we get instead from the wearable devices, some self-reported data, so some questionnaires, and also, let's say, what the users talk with some conversational interface. So of course, if we want to, let's say, provide some tools to people to reduce the negative impact of work-related stress disorders, we can, let's say, target several, let's say, outcomes. So we can provide some tools to improve their sleep habits, to manage their stress, so reduce their stress levels during the days, provide them with, let's say, awareness about an healthy lifestyle, some healthy activity habits, and so on. And of course, as we saw during those mornings, sleep is one of the most fundamental pillars for a healthy lifestyle. So of course, if we have a good sleep, we typically tend to feel better. So we'll try to focus on sleep habits. So if we want to provide some tools to people to improve their sleep, of course, we need to do some personalization, as we were discussing before, because each one of us, and I think also Marcus was talking about this morning, so each sleep is unique. So I may have a sleep need of 4 hours, someone has a different sleep need. So of course we need to build some personalization inside the system. So we'll build typically a user profile for the user that is composed, as you, so the red, I mean, not so red, I think. On top are some, let's say, subjective information. So we have some contextual, some demographics, and some personality information about the user. On the bottom side, you see some, instead, objective data, so data that we get from the wearable devices. So we can use this, of course, to do some biofeedback, some personalized digital interventions that are aimed at sleep improvement. But as we saw in the first slide, if we do some personalized intervention, of course we need to consider that these two parts, so the personality, so how the user perceive sleep, may be different from what we get from the wearable device. So of course, if we design some tools that are based only on the data that we get from the wearables, the user may get frustrated because that doesn't match what he is experiencing. So of course, we need to find a balance between the two. We need to include both information into our models to, let's say, really drive some personalized intervention. So I will discuss a little what we did in the some first studies in order to study this mismatch and what we can do to, let's say, handle this mismatch of information. So what we did as a starting point, we collected data from 27 people, not that big sample size, but still something to start off. So these people were monitored for at least 4 weeks with a Garmin device. So it was a Garmin Venus Q2, and they were asked to wear it both daily and nightly. And they were asked with daily questionnaires every day. We then fused, so tried to fuse these objective features from the wearables and some subjective and contextual information. And what we wanted to study was how the comparison between the perceived sleep quality, so how the sleep quality that was perceived by the users really matched the measured sleep quality from Garmin in this case, and then try to analyze what really impacts the perceived sleep quality, so what are the features that are really interesting to analyze. So the questionnaires that we asked to the participants were 2. So one in the morning, just after wake up, and one in the evening, just before going to bed. And they were focusing on, let's say, collecting some subjective information, so sleep quality and sleep energy, and perceived energy in the morning, so on a 5-point scale. And for the evening, instead, we asked for perceived daily stress during the day, so how much stress they felt during the day, and also some current stress, so just at the time of the questionnaire filling. And then some contextual information. And this is something that also came up in the first half of this track. So all the information that we can really collect that really helps understanding people's sleep. So the data set was then, let's say, composed in this way. So of course the adherence was not so high. That is what we typically experience in longitudinal and in the wild study. So we had a total of 580 nights with sleep data. But then if we merge this data, so these are from the devices, so wearable devices. Then for the evening and morning questionnaires, so the data that, so the nights that had the full set of subjective and objective information, we only had 319 nights that had like the full subjective and objective information. This is because in order to reduce some recall bias. So if I fill in my perceived sleep quality 2 hours after wake up, then it's fine. But if I fill in later during the day, then I may not recall properly what I really experienced. So we, let's say, consider only answers that are very close to the wake up and very close to bedtime. So in order not to, let's say, have some problems in recall bias. So just to give you some information about the perceived sleep quality, and the quality score, the sleep score by Garmin. You see here, so the subjects were asked to report their perceived sleep quality on a scale from much worse to much better than their usual. And in the, let's say here instead, we see the sleep score from Garmin. And as you can already see from this graph here, there is really not such a monotonic relationship between the two. And this is what already exists, let's say, in other scientific studies with other wearable devices. So the perceived sleep quality really doesn't always match the sleep score that is provided by Garmin. So we had a very weak correlation coefficient of 0.2. And of course, if we try to build some basic model to predict the perceived sleep quality from the sleep score, we really get just better than random guessing, so with 25% of balanced accuracy. So of course, as we see here, this mismatch really exists, and that's why it's important to consider both components when we really deliver some personalized interventions. We then went over to study a little bit what are the features that really impact the perceived sleep quality. And you see here, so we report only the significant ones. We see here both objective features and some let's say, reported information. And it's interesting to see that so the positive correlation was found, of course, for the recovery, so amount of time, so amount of recovery at night as measured by the body battery. Then we have the total sleep time, so the amount of time that the user really slept during the night. REM, so both the percentage of REM and the REM count, so how many stages during the night. And then for the let's say, reporting information, if it was a day off, so or a holiday or a day off, so not working. While negative correlation were found instead mostly for perceived information, so subjective information. So daily stress during the previous day had a negative impact on the perceived sleep quality. So the more they felt stress in the previous day, the less the sleep quality, perceived sleep quality the day after. And also on the amount of time they worked and whether they had alcohol the previous day. It impacts this perceived sleep quality. So as we saw, and as I already, let's say, told, we have this mismatch, of course. So we have a mismatch between the subjective and the objective information, and we need to handle it some way. So what we can do, so of course, if we have these personalized models, what we can do, so what we are trying to do also in the project with Resilient now, just to understand in the first days, first weeks, how much the user, so the person is agreeing with some high-level features that we extract from the devices, just to build this basic model. And then we can then steer and guide some our models, our AI algorithms, so it could be the conversational interface or other tools, to also base their say, judgments on this agreement between the perceived and objective data. Second thing is also, as Max was reporting, instead of comparing users with absolute values, could be guidelines or other things, to monitor them in the long term, to analyze their trends, and maybe not only based on some low-level features, but build upon high-level and more reliable features that we can extract easily from the wearable devices. So why this is important, and this is, I'm going to conclude this talk with this really nice example from this paper that is very recent from the Empatica team. So of course the objective data, so the data from the wearable, help us understand the behaviors and the health of people. So you can see here a pattern that was what Marcus was referring to during the Q&A. So wake up, bedtimes, and also activity information of the users over day and weekly averages. So this is the picture that we get only from wearable devices. Then we could collect some subjective and some self-reported information that it would be impossible to get only from the wearable devices. This is, for example, a patient health questionnaire that allows us to understand the perceived health in a standardized manner. And the only way with which we can really get the full picture is by merging all the information together, so both knowledge from the wearables, knowledge from subjective information. And this, for example, sorry, the green, I don't think it's visible. So in this second part, you can see that by merging the information from the activity data and the information from the subjective self-reports, this is the depression score really drops down, and we can link it to, for example, increased levels of activity from the patients. So we can really understand the full picture, and this is the only way with which we can really drive truly personalized digital interventions that can be aimed at improving sleep, improving activity, but in general to improve really the health and the lifestyle of people. Thank you very much for your attention.